Good day everyone. So this time we'll be talking about trigonometric functions of an acute angle. So here is an illustration. So we have here r is considered as our hypotenuse and y is the opposite and x is the adjacent. So how to find the value for r? R is equal to the square root of x squared plus y squared. Okay, so these are the ratios when it comes to trigonometric functions. So sine theta is equal to y over r, which is the opposite over the hypotenuse. We have the cosine theta is equal to x over r, which is adjacent over the hypotenuse. And the tangent is equal to y over x, which is the opposite over the adjacent, and x should not be equal to 0 because it will be restricted at x is equal to 0. And we have cosecant theta is equal to r over y, which is the hypotenuse over the opposite, which is y should not be equal to 0. And of course, secant theta is equal to r over x, which is the hypotenuse over the adjacent, where x is not equal to 0 still. And cotangent theta is equal to x over y, which is adjacent over the hypotenuse. Y is not equal to 0. So these are the ratios that we're going to use in these trigonometric functions of an acute angle. So at this point, we will be looking into the signs of trigonometric functions in the different quadrants. So we have here, I will be illustrating to you here. This is our Cartesian plane. So we have here the first quadrant, the second quadrant, and the third quadrant, and the fourth quadrant. So this is our first quadrant, and this is the second quadrant, the third quadrant, and this is the fourth quadrant. So we will have to look into the sign of the theta. So we are going to find the signs of the trigonometric function. Okay, we'll be looking into the signs of the trigonometric functions into the different quadrants. So we have here the sine theta, the cosine theta, the tangent theta, the cosecant theta, sec theta, and the cotangent theta. So here, I'll be illustrating to you how we come up with the sign. What is the sign of the sine theta in a quadrant 1 and in a quadrant 2, 3, and 4. So let us have first an illustration here. So in this illustration, so this one, let us assume this as a right triangle. So this is the y, the x, and the r. In this quadrant number 1, the sign for our x is positive, right? And the sign for our y is positive. And of course, the sign for our radius or the hypotenuse is always absolute, which is the positive. So in this case, this is our theta. So we will have what is the value of sine theta in quadrant number 1. What is sine? Sine is equal to the opposite over the hypotenuse. So therefore, plus positive divided by positive, the result is positive. Okay. In quadrant 1, we say that sine theta is positive. In cosine theta, which is adjacent over the hypotenuse. So therefore, positive divided by positive, still the result is positive. That's why in quadrant positive over positive, x which is positive and the radius which is positive divided by this part, we have the positive of the cosine in quadrant 1. Tangent. Tangent is equal to the opposite over the adjacent. So therefore, positive divided by positive, the result is positive. Next, we have cosecant theta. So cosecant theta is equal to the hypotenuse, which is the positive, and the opposite, which is the positive. Of course, positive divided positive, the result is positive. So in secant theta, secant is equal to the hypotenuse, positive, and the adjacent is positive. So therefore, we have come up with the secant, which is positive. In cotangent theta, cotangent is equal to adjacent x and the opposite, which is the y. So positive divided by positive, of course, the cotangent is positive. So we're going to, as we look at quadrant number 1, all functions are positive. Okay, so all functions are positive in quadrant number 1. So let's try in quadrant number 2. What are the signs of these trigonometric functions? So we have here. Okay. So in this sign is negative. So therefore, our x is negative. Still, the y is positive. And the radius is absolute as positive. So this is the theta. So let's start with the sign. The sign is opposite y over the radius, which is positive also. So positive divided by positive. In this time, sign is positive. Okay. Next is cosine theta. Cosine is adjacent over the hypotenuse. So adjacent is negative divided by positive. The result is negative. So tangent. Tangent is opposite over the adjacent. So therefore, the opposite is positive divided by the negative. The result is negative. So in cosecant theta, cosecant theta is equal to the hypotenuse, okay, the hypotenuse over the opposite. So positive divided by positive, the result is positive. And in secant theta, secant is equal to the hypotenuse over the adjacent, which is the hypotenuse which is positive and the adjacent is negative. Of course, the result is negative. And in quadrant number 2, cotangent. What is cotangent? Adjacent over the opposite. So adjacent, the negative divided by positive. So of course, cotangent is negative. Okay. So take note, in quadrant number 2, only sine theta and cosecant theta are positive. Okay. In quadrant, let's proceed to quadrant number 3. Let's check what are the signs of these functions, trigonometric functions. Let us have first this part. Okay. In quadrant number 3, this is negative side or x, and the y is negative. Okay. And the r is always positive. So therefore, let's check if what is the sign of our sine theta. Sine is, if this is a theta, sine is opposite over the hypotenuse. So negative divided by positive, the result is negative. Okay. Next, we have cosine theta. Cosine is equal to adjacent over the hypotenuse. So negative divided by positive, the result is negative. So here in tangent theta, tangent is equal to opposite over the adjacent, which is negative divided by negative. Of course, the resulting one is positive. So ato sang i-line, we'll have to make a line here so that it will be okay for you to look at here. So we have this. Okay. So proceeding to the next, which is cosecant theta in quadrant number 3. Cosecant theta in quadrant number 3 is radius or the hypotenuse positive divided by the opposite is negative. Of course, the result is negative. And in secant theta, what is secant theta? Secant is hypotenuse. Hypotenuse, which is positive, divided by the adjacent, which is negative. Of course, the result is negative. And we have cotangent theta. Cotangent is adjacent, negative, divided by the opposite, which is negative. Of course, the resulting one is positive. So in quadrant number 3, only tangent and cotangent are positive. Okay, these are the positive. Tangent and cotangent are positive. Okay, proceeding to quadrant number 4. Okay, in quadrant number 4, so this is our y here is negative, our r is positive, but our x is positive because that is in quadrant number 4. So let's check first the sine theta. Our sine is equal to the opposite. Okay, if this is our theta, the opposite is negative, and the hypotenuse, which is positive, divided by positive, of course the result is negative. Cosine theta. Cosine is adjacent. Adjacent over the hypotenuse is positive. Both are positive, so therefore the resulting one is positive. Tangent. When talk about tangent, opposite over the adjacent. Adjacent. So negative divided by positive, the result is negative. Cosecant theta. Cosecant theta is equal to hypotenuse divided by the opposite, which is positive divided negative, the result is negative. So secant is hypotenuse, r, positive, over the adjacent, which is positive. Of course, the resulting is positive. And cotangent. Cotangent is adjacent divided by the opposite, which is adjacent is positive and negative, of course, negative. So if we're going to summarize this one, if we're going to have this part in a Cartesian plane, so in quadrant number 1, all functions are all positive. In quadrant number 2, only sine theta and cosecant theta are positive. And in quadrant number 3, tangent theta and cotangent theta are positive. And in quadrant number 4, cosine theta and secant theta are positive. So take note of this sign, all positive in quadrant 1, sine and cosecant in quadrant 2, positive, tangent and cotangent in quadrant 3, and cosine theta and secant theta in quadrant number 4. Those are the signs of trigonometric functions. Okay, so let's proceed with the problem. So let's check whether you learn on the signs of the trigonometric functions, and of course how to get or to solve for the remaining trigonometric functions. Here's the given. Tangent theta is equal to negative 15 over 8, and theta is in quadrant number 2. Okay, so if we're going to check this one, we have here the Cartesian plane. So we have tangent is negative and the theta is in quadrant number 2. So therefore here, this is in quadrant number 2. Okay, so this is our theta. So in tangent, tangent is equal to the opposite over the hypotenuse. So therefore, our opposite here, tangent is opposite over the adjacent, rather. Opposite over the adjacent, so our opposite here in this case is 15, which is positive. Why? Because in this part, positive, and this is negative, the adjacent, which is 8. So why is it negative in this part? Because understood that the functions or the sign that is positive in quadrant number 2 is for the opposite. And in quadrant number 2, this side is negative. So the sign will be directed to the x-axis. Okay. So in order to find the radius, we have to compute r is equal to the square root of x squared plus y squared. Okay. So r is equal to the square root of 15 squared plus the negative 8 squared. So r is equal to, if we're going to compute that one, we have 17. So therefore, the radius is 17. And since the radius is always positive, we will have the sign of positive. Okay. So next, we need to find the remaining trigonometric function. So let's start with sine theta. What is sine? Sine is equal to the opposite. What is the opposite? The opposite is 15. And the hypotenuse of 17. Okay. So we have here, I'll be listing here. So our opposite is equal to 15. Our adjacent is equal to negative 8. And the hypotenuse, which is 17. For us to locate easily the given. So what is cosine? Cosine is equal to adjacent over the hypotenuse. So adjacent, which is negative 8, over the hypotenuse, which is 17. So we're going to list down all the givens. Okay. Tangent theta is equal to, what is tangent? Opposite over adjacent. So what is our opposite? Which is 15 and the adjacent of negative 8. Next is cosecant theta. In cosecant theta, we have hypotenuse, which is 17, over opposite, which is 15. So next we have secant theta. In secant theta, in secant theta, our function is, the ratio is hypotenuse, which is 17, and negative 17, secant theta is 17, and the adjacent, which is negative 8. And cotangent theta is equal to, what is cotangent? Cotangent is adjacent over the opposite. What is adjacent here? Adjacent is negative 8 over 15. But we could still rewrite that one as 8 over 15. So not just like in the directed to negative 8, but both of the fractions, negative 8. All of this one, we could rewrite as one as negative 17 over 8. So the center part, because it goes for numerator and denominator. So again, these are the remaining trigonometric functions aside from the tangent theta. Okay, so let's proceed with number 2. Okay. In number 2, we have the problem. Sine theta is equal to the square root of 2 over 6 and cosine theta is lesser than 0. So, we will check what quadrant this problem falls. So, if we're going to check that sine theta is positive, only the sine theta is positive is in quadrant 1 and quadrant 2. Okay, these are the function sine theta is positive. So therefore, we have to choose whether of this one. But take note, it stated that cosine theta is lesser than 0. So therefore, we can say that negative. So in this part, we will not choose 1, but we have to choose 2 because in this part, cosine is negative also and sine is positive. So we have to choose this part. Okay. So sine, this is the theta. Sine is equal to the opposite, which is the square root of 2, and the hypotenuse, which is 6. So in this case, square root of 2 over 6. So we have to locate for x. So what is the value for x? Is equal to the square root of 6 squared minus the square root of 2 squared. Okay, x is equal to the square root of 36 minus 2. So therefore, x is equal to positive and negative square root of 34. So we have here the two values of x. But what we're going to choose is, in this quadrant, x is negative, because in quadrant number 2, x is negative. So therefore, we would have to choose square root of 34. Why we need to choose square root of negative 34? Because in quadrant 2, which is x is negative, not positive. So choose negative sign. Okay. So let's go to sine theta. Okay. Paano po ang sine theta? So let's have first our opposite. What is the opposite? The square root of 2. So this is our opposite. Para hindi tayo be careful of this given. So next we have opposite. Next is the adjacent, which is negative square root of 34. And the hypotenuse, which is always positive, which is 6. So therefore, the sine theta is given, square root of 2 over 6. Next is cosine theta. Cosine theta is equal to the adjacent. Adjacent, negative square root of 34 over the hypotenuse, which is 6. Okay. So next is tangent theta. So tangent theta is equal to the opposite over the adjacent. Opposite is square root of 2 and the adjacent is the square root of 34. We could still simplify this one. Square root of 2 over, by the use of factoring of algebra, square root of 2 times the square root of 17. So cancel this part. The remaining is 1 over the square root of 17. This is negative, right? Negative. And this is negative. And this is negative. Okay. So multiply by rationalizing square root of 17 over the square root of 17. So therefore, we come up with the square root of 17 over negative 17. So, or equal to negative the square root of 17 over 17. So this is the value for our tangent. Next, we'll proceed with the cosecant. The cosecant theta is equal to the hypotenuse over the opposite. So what is the hypotenuse? Which is 6, and the opposite of square root of 2. So we have to rationalize this part. Square root of 2 over the square root of 2. How to rationalize? Just multiply it with, example, this one is square root of 2. Just multiply it by square root of 2 over square root of 2. Still, it would not affect because it equals to 1. So square root of 2, that is 6 square root of 2 over 2. So therefore, we have factorable. We have, this is 3. So therefore, the answer is 3 square root of 2. Okay. Next, we have secant. Secant theta is equal to, what is secant? Secant is hypotenuse over the adjacent. Hypotenuse, which is 6, and the adjacent is negative square root of 34. Negative square root of 34 times square root of 34 over square root of 34. The result is 6 square root of 34 over negative 34. That is, we could still simplify this part. Okay, so this is 3 square root of 34 over 17. That is divisible by 2, right? So the 3 square root of 17. And the last part, I'll just have this one in cotangent. Cotangent theta is equal to negative square root of 34 over square root of 2. So is equal to, still that is factorable, square root of 2 times the square root of 17 over the square root of 2. So cancel. So therefore the answer is negative the square root of 17. So this is for cotangent theta. So these are the functions. Now we got it. So I hope you learned this part number 2. Okay, so let's proceed now with problem number 3. So in problem number 3, we have here the problem. Secant theta is equal to the negative 4 and sine theta is greater than 0. So let's have first secant theta. In what quadrant secant is negative? So, and sine theta is positive. So therefore, we could project that sine theta is positive in only for quadrant 1 and quadrant 2. So we have to choose in quadrant 1, secant is positive. So therefore, positive still. So therefore, we have to choose quadrant 2 because understood because only sine theta is positive in quadrant 2. So therefore, we could say that in secant theta is negative in quadrant 2. So we have quadrant 2 here. Okay. So secant theta is equal to, what is secant? Secant is equal to hypotenuse over the adjacent. So secant theta is hypotenuse over the adjacent. So I will just put here the negative because hypotenuse will not be negative, always positive. So therefore, the negative should be placed in the adjacent part. So therefore, secant is negative 1 and this is 4. So we're going to look for the third. Okay, so the opposite sign or the opposite is equal to the square root of 4 squared minus negative 1 squared. So we have here the opposite here is the square root of 16 minus 1. So the opposite is equal to positive and negative square root of 15. What we're going to choose, whether positive or negative, we should have to choose positive because in quadrant number 2, y is positive. So therefore, positive, we have to choose positive 15, square root of 15. So let's start now. Sine theta is equal to hypotenuse. But before that, we will have the given. Adjacent is equal to negative 1. Opposite is equal to positive square root of 15. And the radius is equal to, or the hypotenuse is equal to 4. So, we have here sine is equal to the opposite, which is square root of 15, over the hypotenuse, which is 4. Next is cosine theta. So, cosine theta is adjacent over the hypotenuse. What is adjacent? Negative 1 over the hypotenuse, which is 4. Next is tangent. Tangent theta is equal to the opposite over the adjacent. What is opposite? Square root of 15 over the adjacent, which is negative 1. So therefore, the answer is negative square root of 15. Okay. So next is cosecant theta. In cosecant theta, we have cosecant is equal to the hypotenuse, which is 4, over the opposite, which is the square root of 15. So rationalize square root of 15 over the square root of 15. So the answer is 4, the square root of 15 over 15. Next, we have secant theta. In secant theta is just the opposite of cosine theta. So therefore, we have 4 over the negative 1 is equal to negative 4. And cotangent theta is equal to negative, cotangent is equal to adjacent negative 1 over the opposite, which is square root of 15. So just rationalize square root of 15 over the square root of 15. So therefore, negative square root of 15 over 15. So because this is rationalized 15 times square root of 15, the answer is 15. So these are the remaining trigonometric functions. So thank you for watching, and I hope you learned something today, and God bless everyone. Okay, so to test whether you're listening, please comment your answer. Try this. Find sine theta and tangent theta given that the cosecant theta is equal to the negative square root of 3 over 4 and sine theta is greater than 0. So try to solve that one at home, and I hope everyone you are enjoying the moment while you are watching. God bless everyone. Comment your answer.